What is the meaning of beauty in mathematics? What is aesthetic in mathematics? Improper Riemann integrals are a mathematical object that is meant to expand the range of functions of domains in which we can integrate some functions. An improper integral is some with some notation could be taken as this symbol. It is this mathematical object, right? And this is in turn defined as some limit over when t goes into infinity of minus t and t of f, right? But what's the problem with improper integrals? Why do I regard them as ugly in mathematics? It is because this definition lacks the generality of mathematics. And why is that? Because when you go from this, this works when you are with functions in one dimension, but once you start to get into higher finite dimensions like R2, like the whole plane, or higher dimension R3, R4, and so on, this definition, or wait, not the definition, but this sense of defining the improper integral starts to fail, and it starts to get complicated. But it is not ugly because it's complicated, but it is ugly because it lacks generality. And why I mean with that? Well, you see in R2, for instance, let's suppose you have a plane here. This is R2. So suppose you want to integrate some function that is defined on the whole plane on R2. What would you do? Well, you could define the improper integral over this whole space as two successive integrals of this form, right? You first will integrate over the whole x-axis, and then you will integrate over the whole y-axis, and you will get the whole plane. But what happens if there are some portion of the domain that in which the function is not defined? For instance, what happens if, I don't know, the origin is a point in which the function is not defined? Well, there are some ways in which we can go around those problems whenever those areas of non-definition are simple enough to construct some functions in which you could with as t grows into infinity, you could approach the origin asymptotically with some function like the exponential of minus t or something like that. So in principle you could do it for some, as I told you, simple domains. But what happens if we have the same in the same R2, and I hope you're able to see this. What happens if we're in R2 and the domain is not the whole plane but some star-like a domain that goes into infinity in the axis? Well, in this case it could be in fact it could be tractable still, because there's some pattern in that domain. But as you are seeing, as I start to get to bring more examples, the way in which we could define the integral over these domains becomes increasingly complex. And for some domains I gather that there may be not any way to do it, because the domain is so complex, the unbounded domain. We are talking, of course, about unbounded domains. So because the domain is so complex that you cannot think or design or construct any way to tackle that problem. I don't know, it could be some amorphous domain like some pattern like this, and so on, or it could even may not be continuous at all. It could be defined on this part, and then it could have things like that. And we are still on R2. This is still R2, but it gets increasingly complex. And what happens when we go to higher dimensions? What happens with R3, with R4, in which our intuition about the space starts to fail? How could we have this improper integral defined? Well, this is more or less the reason why I'm saying that the concept of improper integral doesn't satisfy, or it's not in line with the concept of aesthetics in mathematics. As I told you, because it is not general enough, because it is not something that you could define for any unbounded domain. For those simple domains like in just a real line, it is pretty much clear that you can always define it. And even then I may have some doubts on that, but it could be possible to be defined. It could be easily be defined. But on R2 then we start to have some problems, like this weird domain here, this weird unbounded domain here, and when you start to go into higher dimensions, well, I think it may be impossible to define as some improper integrals with limits like this. I think it could be impossible. I'm not saying that with mathematical confidence that there exists some function or some domain in which some function cannot be improperly integrated over, and I'm talking of course about the Riemann integral. So this is why I think that improper Riemann integrals are ugly in mathematics. Well, what's then the another way to solve these problems, because we still want to integrate over those weird domains? Well, the solution, the alternative, is the abstract integration, the Lebesgue integral, and so on. But for those integrals, it doesn't really matter if it's unbounded or not. You could always integrate, at least for given the definition of the Lebesgue integral. So it expands the range in which you can have a proper integral, and that's why it has more generality, and that is a good quality of a mathematical theory. So this is the reasons why I consider that improper Riemann integrals are ugly in mathematics, and also the reasons why I think you should consider learning abstract integration, the Lebesgue integral, to avoid these ugliness in your mathematical work.